The combined gas law is P1 times V1 divided by T1 equals P2 times V2 divided by T2. The combined gas law combines Boyle's law, P1 times V1 equals P2 times V2. Charles' law, V1 divided by T1 equals V2 divided by T2. And Gay-Lussac's law, which is P1 divided by T1 equals P2 divided by T2. The reason that they combined all these laws to make one large law is because it is easier for people don't have to memorize each law as it's on its own, and they only have to memorize one law. In the combined gas law, the amount of gas is fixed, and all of the relationships in the combined gas law are the same as in the other laws. So pressure is inversely proportional to volume, which means that as the pressure goes up, the volume goes down, and vice versa. And pressure is directly proportional to temperature, which means that when the pressure goes up, the temperature goes up, and volume is directly proportional to temperature, which means that as the volume decreases, the temperature decreases, and when the volume increases, the temperature increases. Now I'm going to do a practice problem to show you how the combined gas law is used. The first step of using the combined gas law is that you need to find out what you know and what you're trying to find. As you can see, we know what P1 equals, which is 110 kPa. We know that P2 is 440 kPa. We know that T1 is 30 degrees Celsius. We know that T2 is 80 degrees Celsius. And we know that the V1 is 2 liters. What we don't know is V2, and that's what we're trying to find. The second step is we need to convert degrees Celsius to kelvins. And to do that, we need to add 273 to the amount of degrees Celsius. So our new T1 is 303 kelvins, and our new T2 is 353 kelvins. As you can see here, this is how I used the actual formula to find out what V2 is. We've had to isolate V2. So I first multiplied T2 on the right side and on the left side to get rid of the T2 on the right side. So now our equation is T2 times P1 times V1 divided by T1 equals P2 times V2. Then I divided by P2 to get rid of the P2 on the right side. So now our equation is T2 times P1 times V1 divided by T1 divided by P2. Then I fixed the equation to show the connections. So I did V1 times T2 divided by T2 times P1 divided by P2 equals V2. And here is where I plug in my numbers. And as you can see, my final answer is 0.582 liters. The way I got liters was, first we canceled out kelvins because both the top and the bottom were in the unit kelvins, so they were able to be canceled out. Then I canceled out the kPAs because they were both also kPa. So all we were left with was liters. And to check my work, here is what I did. Both sides had to be equal, so I put P1, which is 110 kPa, times V1, which is 2 liters, divided by T1, 303 kelvins, equals P2, 440 kPa, times V2, 0.582 liters. Our answer from our work divided by 353 kelvins. And our final answers were 0.726 from the left side and 0.7255 from the right side. And in the end, they are equal because we have to round it up for the significant figures. I hope you understand what the combined gas law is now, and have a nice day.